Welcome back to the video for lesson 2.5. In this lesson, we're going to analyze the graph of a function. The last couple lessons, we've been talking about functions and how to decide if they are a function. And now we're understanding that we have a function, but we want to learn what we can learn from the graphs of a function. So there's even and odd functions. An even function is considered symmetric around the y-axis. So if we have an x value and we evaluate the function at x, that outcome is the same as if we evaluate that function as at the opposite value of x. An odd function is symmetric to the origin, so around the point 0, 0. So if we take f and we evaluate at negative x, it's equal to the opposite of if we evaluate the function at a positive x. So let's look at a couple examples here. So we have the function h, and that function is 2 times the absolute value of x. So let's make some little tables here. Let's put in 1. So if we put in 1, we get 2. Let's put in a negative 1. So if we put in a negative 1, 2 times the absolute value of 1 is a negative 1 is 1. So it's 2. Okay. Let's put in, okay, so then we can look up here because f evaluated at 1 is equal to 2, and f evaluated at the opposite of 1 is also equal to. Let's just put in another value and just confirm this. So I'm going to put in a positive 4. So 2 times the absolute value of 4 is 8. And then a negative 4, 2 times the absolute value of a negative 4 is also 8. So it's an even function. Okay, let's look at the next one. Let's make an x. This is an f function, and this function says we're going to take the x and add 1 and then square that. So again, I'm going to try 1 in for x. So 1 plus 1 is 2, 2 squared is 4. Let's put in the opposite of 1. Negative 1 plus 1 is 0. 0 squared is 0. So it's not even, because if it were an even function, these two would equal, these two outputs. And we put in 1. So the opposite of 1 gave us 0. If it's odd, then the negative of the f of x would also be 0. But the negative of f of x would be the negative of 1 is equal to a negative 4. So they're not odd either. So it's a neither. Try it out with inputting some values. Another thing that we can learn from graphs is where they increase and decrease. So a function of f is increasing on an open interval I if for any a and b in the interval, when a is less than b, then the function at a is also less than the function b. A function is f is decreasing on an open interval if on an interval, if a is less than b, then this is supposed to be greater than. The function of a is greater than the function of b. So let's look at a graph and see what we can point out from this graph. It says find the intervals where f is decreasing. So we can see visually it's decreasing, but let's prove it up here. So if we, it looks like it's decreasing from a negative 2, 4 to 1, 3. So we have a is less than b. -2 and 1. The A is -2 and 1. A is less than B. And then the function of A has to be greater than the function of B. So the function at a -2 is 4, and that is greater than the function at B, which is a -3. So it's decreasing it's decreasing, and it's always, you're defining it by the X values. It's decreasing from a -2 to 1. So from here to here, it's decreasing. And then it's also decreasing. So it's visually decreasing here. And you can also see that it's decreasing there between 2 and 5. B says, find the intervals where f is increasing for the function. Okay, so increasing means that when A is less than B, then f of A is also less than f of B. So it looks like we're increasing here. So A is a -4, is less than a -2, the X values. And then f of A is 0, and that is also less than the f of B, which is 4. So it's increasing on the interval of a -4 to a -2. And then it's also increasing here on the interval of X from 1 to 2. Letter C says, what is the domain for the above function? So the domain is what can go in. So what are possible inputs? That's what we're looking for. And so the min to the max, that's how we're listing them. So the min is -4. And I'm going to put a bracket around it because it's a solid circle. It can equal a -4. And the largest X it can be is a +5. And that also gets a bracket because it's got a solid circle. And then the range are, what are the possible outputs? What are the possible outputs? And then that's going to be in a min and max form as well. And so the smallest y, it looks like, is a -3. -3 right here. And the largest is a +4. So we write that the interval that its range is from -3 up to a +4. And those are the y values. Okay, the last topic of this lesson is on average rate of change. Average rate of change is essentially the slope. But because we're not dealing with just linear functions, it's not called slope. It's called average rate of change. And so, but it's the same thinking, because it says the function evaluated at x2 minus the function evaluated at x1. So that would be the difference of your y's, just like in slope, over the difference of your inputs. So it says find the average rate of change for the following functions. So we're going to evaluate the function at 3 and then evaluate the function at 2 and take the difference. And then we're going to take 3 minus 2. So the function evaluated at 3 is 3 times 3 squared minus 1. 27 minus 1 is 26. So that's 26. And then the function evaluated at 2 is 3 times 2 squared minus 1. Or 3 times 4 is 12 minus 1 is 11. So 26 minus 11 over 1 is 15 over 1 is 15. Let's look at the average rate of change for the next function. So this is going to be the function evaluated at 2 minus the function evaluated at 4. Function evaluated at 4 minus the function evaluated at 2 over 4 minus 2. So the function evaluated at 4 is the square root of 4 plus 3 is the square root of 7, which is irrational. So we'll just leave it at that. And then the function evaluated at 2 is the square root of 2 plus 3, which is the square root of 5. So we will leave at that. And then 4 minus 2 is 2. So because the square root of 7 and the square root of 5 are irrational, we're just going to leave it. And then the last one is going to be the function evaluated at -4, subtracting the function, the function evaluated at a -2, subtracting the function evaluated at a -4 over a -2, subtracting a -4. So let's evaluate the function at a -2. The absolute value of 2 is 2 minus 5 is a -3. And then the function evaluated at a -4 is the absolute value of a -4 subtracting 5 is 4 subtracting 5, which is a -1. So subtracting a -1 over a -2 subtracting a -4 is a -2 plus 4. And then this becomes a -3 plus 1. So we have a -2 over a +2, which is a -1. And that's all for that lesson. Reach out if you have any questions.